How's it going, guys? Let's go over lesson 1.5. After this lesson, you should be able to make and interpret histograms of quantitative data. It means you get numbers from those. Describe the shape of the distribution, so our socks, and then use histograms wisely. So remember, quantitative data is you're getting some kind of numbers, and you can take the average of those. That's what quantitative means. Note, it is similar to bar graphs, except for, number one, there are no spaces. So no spaces between the bars. Number two, the horizontal axis has numerical values. That means they have numbers. Remember, horizontal is the going this way, that is your x-axis. The vertical axis, which is your y-axis, shows the same values as the bar graph. Right, so how do we make a histogram? We need to divide the data into something called classes or bins of equal width, we need to find, what's another word for frequency? The count. Or the relative frequency, which is what? The percent. So that should be a review of individuals in each class. We need to label and scale your axes and draw the histogram. The height of the bar equals its frequency. That one should be there, or relative frequency. All right, let's do our first example. Foreign-born residents. What percent of your home state's residents were born outside of the United States? The country as a whole has 12.5% foreign-born residents, but states vary from 1.2% in West Virginia to 27.2% in California. The table represents the data from all 50 states. The individuals in this data are, so if you look at your graph, go ahead and put your finger on the individuals. The individuals are the different states. And the blank is the percent of states residents who are foreign born. So going back to the idea, instead of individuals, then these percents here, that is the variable. Okay, so we need to complete below. We need to complete the frequency table. So frequency means we need to count them, and then we need to convert those into percents. Go ahead and press pause. This should be like a review or a warm-up. Basically, you're counting the number of states that have between 0 and 5%. For example, if it is Alabama, 2.8%, that is between here, and I'm just going to put a tally mark. Okay? Go ahead and do that yourself. All right, if you went through and counted each of these Again, I recommend actually putting a little check mark for each one of those, like a 7. That's between 5, and then your inequality is less than 10, so that means it does not include 10. So if you do that, you should have gotten a count of 20 here. 13, 9, 5, 2, and then I got a 1. And then if you count up all of those up, you would have gotten 50 states. So that idea that there are a total of 50 states helps you make sure you count. It is easy to lose one of these. Okay, so quick review. To go relative frequency, you just make it a fraction. Zoom in here, so that essentially you're just doing 20 divided by 50, which would give you a 40%. And then 13 divided by 50. If you know your fractions, you just double it, so you get 26 over 100, and percents out of 100, so that would be 26%. And then you can do the rest of those. That would give us 18%, 10%. Remember, that's 4 out of 50, which is equivalent to 8 out of 100, which is 8%. And then we have 1 over 50, which is, I'm not showing all of those, just hopefully you know how to do those. 2%, and then of course if you add up all of the percents together, you'll get actually 100%. So super important actually that you actually know the number of states. That actually helps you figure out that you're getting a total of 50 states and your relative frequency adds up to 100%. All right, if you go to the next page, it says create a histogram based on a table in 1A. So if you look above, we have 2 types of histograms we need to create. I'll do one of these. You have the percent of foreign-born residents, and on your quizzes or tests, if I ask you to do free response, I want you to write all that out. And then basically the first graph is a number of states. Number of states. Why is that? Because that is our frequency table. And then over here, this is the percent of states. This is our relative frequency. So again, percent of foreign-born residents. Let me do the first one, and then you can do the second one. So I need to create these class or bins. So I want them of equal length, and I already kind of have those already. The classes there kind of tell me, so 0 to 5. So let's go down here. And I'm going to make these of equal length. So there's 0 to 5. Hopefully that's enough. 10, 15, 20, 25, 30, 35. And then I'm going to go, the highest percent that we've found was, by number of states, was the highest was 20. So 5, 10, 15, 20. Okay, and as I create this one, so the first one has 20, and then the second one had 13. So this dotted line might be helpful for you. That's the 15, so I don't want to go all the way up. So, and then I have 9. So again, something below this. And then a 5, and then a 2, then a 1, and I didn't need the 30 to 35, and you can go back and erase your dotted lines there. Oops. Okay. And then you would just do the same thing for your relative frequency table from above. I have 0, 5, 10, 15, 20, 25, really head up to 30. And then on the vertical axis here, I'm going to use percent. So I have 10, 20, 30, 40. It's white. 40, 30, 20, 10. And then we had 40%. And notice how they are histograms, so they are touching. And then we have 26%. Remember, these are of same widths here. And then how many between the 10 and 15? That was 18%, so less than 20. And 15 to 20 had 10%. And 20 25 had 4%. And then 2%. Okay? So there are my histograms. Now I wanted to give us a big idea of what we're doing here. If I actually took the data from above, do it over here, and let's just say we did last week's lesson. Let's say you made a dot plot. And what does your dot plot might look like? It might look something like this. Just drawing something really, really quick. And let's just say you have your dots, right? I'm just doing this really quickly. And let's just say I put them in bins. Like the bins down here. So I'm dividing them into bins. And then I squish everything in all the dots into a single file line. So I had the pink ones, right? And then you would have something like this. So essentially, dot plots actually form a histogram. So we already did the same. Remember, we were drawing these curves above our data. Do you remember that? You're kind of doing the same thing even in this graph. Does that make sense? And you actually get the same shape. So describe the pattern and look at any departures from the pattern. Hint: when your toes are cold, you put on what? Socks. Socks. Oh, where'd I go? All right, go ahead and pause the video and then go ahead and see if you can fill that out based on the graph of the histogram. Think of the vocab words we've used before. All right, so you're looking at our histograms from above, and we're just looking at any patterns that we see. S stands for shape. What does our shape look like? Is it uniform and looks normal? No. All the data, you're going skiing going down this direction, so there is no data to the right. So this would be right skewed is one way you can describe this. You can say, think of a mountain. Use a different color. Up here is a peak, or the highest point, and it's singular. There's not multiple, so we can say single peak to the left. That kind of represents the states. Most of the states are between 0 and 5% of foreign-born residents. All right, let's go to O. O stands for any outliers. Remember, it's just based on what we see. I don't see anything. They're all connected. That's a good one. If I'm going to make up this bar right here, if you had a bar like way out here, notice there's this kind of gap here. This would kind of make it obvious that that's an outlier. There's going to be a formula, but I would say no outliers. Okay, what does C stand for? C is center. Okay, what's happening from our center? Remember, if you have something, let's put that. If you have something that's skewed, the best measure of center is your median. And we'll go over that later in another lesson, but the median falls between. So how do you actually find the median? This one's not going to be fun because there's like 50 states, right? And what I'm trying to say is, if this was 40 and that was 19, no, that was, might be easier on this side. 2013, 9521, 9521. Okay, so there's 50 states, and if you have the numbers 1 to 25, and then 26 to 50, there are 25 numbers here and 25 numbers here. So to find the median of these numbers, we talked about mean, median, mode previously, you actually have to take these two numbers, the average of those two states. And so it's between the 25th and the 26th state. That is our median. Okay, so here is, count with me, there's this 20, and then, so just pretend this is like 1, 2, 3, 4, 5, 6, 7, 8, all up to 20. And then over here, this would be up to 5, because right there is 5. And then somewhere right there is my median. The 26th state is between the 5 and 10%. 5 to 10% of foreign-born residents. Falls between the 5 to 10% of foreign-born residents. Okay, so how I found that again is just count the number of states. You have 50 states. The median is between the 25th and 26th state, right? If you have 50 numbers, you wrote them all out. I don't want to write them all out. And in the exact middle is between the 25th and 26th. There's 25 to the left, 25 to the right. And how I count that is, again, going from, this represents 20 states, and then using the bar graph, that's 25. And there's the 26, and that's in this particular bin, which is 5 to 10%. Okay? And the last one, what is our spread? What is our spread? Like jam, like butter, right? I notice that the foreign-born varies between, how far do we go? From less than, remember those are our comparing words when it says describe, right? Less than 5% to, what was our max? To over 25%. So I want to note that. Remember, I'm using those vocabularies. Where did I get that number from? That is our lowest percentage. Less than 5%, right? So we had one that was, I think, like 2%. And then this is our max. Okay? All right, let's go on to the next one. Create a frequency histogram based on the following data. So there's the males and females again. Let me make sure I have all that data there. Yep, 68 is the most. And so one side you will have females, female height in inches, and over here you will have male heights in inches. And let's create, I didn't specify, but let's create a, oh I did, perfect, that's what I wanted. Let's create a frequency one, so you just have to count, okay? Now, the first question you need to think about as you look back up at your notes is we need to divide this into different classes or bins, okay? So think about all the numbers that you see. Let me do the first one with you, and then you can pause and press the second one, okay? So I recognize for female heights, the minimum or the lowest number that I see there on the list, go ahead and circle it. I'm going to do it. That's 58. Which means that the smallest number that I'm going to have here on my bin is 58. Okay? That's my little earthquake, the squiggly. Remember to skip all the numbers between 0 and 57. And then I'm going to look at my max. The max height I see is... where am I at? Max height I see is maybe 68. Okay, so that means let's count here. So let's count by 2. 60, 62, 64, 66, 68, and 70. Okay, so let's make sure we understand. This one is going to represent 58.0 to 59.9. And this next bin or class will represent starting at 60, I think at like $60 to like 61.9. Okay, it doesn't include the next one up. Okay, so remember you can make a, I'm going to have my bins 58 to 60, 60 to 62, 62 to 64. So essentially it just means it might be easier. Let's try that again. This would be 59. Does that make sense? And then this is 61, 60 and 61. And then the next one, 62, 63. So they can only have 2 numbers in the bin. 64, 65, 66 to 67, 68. To 69. So let's count. I'm going to use this one. So 60, 59, 62, 59. Again, use these check marks, super helpful. I'm just using a frequency table here to count out my numbers. 60, 62, 64, 68, 63. Again, don't mark over the number, you want to see it. 58, 64, 64, 2 of those. 65, 62, 61, 61, off the page there, and 60. Okay, so there's my counts. And then on this left side, I can write, this is my frequency. How many female students are of that height? Okay, so I have 0, 1, 2, 3, 4, 5, and if anyone, 6. And so when I make my numbers, the question is how many were between 58 and 60? Well, we had 3. So I'm going to go up to here. right? Do you see how it represents 3 there? And then 60 to 62, so put check marks. I have 4 of those. So that one's going to go up 1 higher. And between 62 and 64, there are 4 of them. Uh, 62 to 64, I think there are 5. I think I missed a number. That should have been 5. Nope. This is 4. This one's 5. Good thing we have pencils that we can erase. So it goes up to 5. So 3, 5. And then the next one is 4. Then 5. 66 to 68. There's 1. And there's 1. Okay? So there's our histogram. Use pencil. Classes should be the same. Count them off. Use a frequency table. Go ahead and press pause. I want you to finish the males. And I'm going to go ahead and work that out. And then you press play. Then you'll actually see the answers. All right. There you go. I did my frequency table there in white. And then I did tally marks for my frequency, just counting them. And then I have those bins here in white. These bins here represent the numbers here at the bottom. So from 60 to 61.9. And then I counted 2 there. So you might notice something about the males. And we already know that. It's more spread out. There's more data going further out. And so something that's hopefully you recognize, you're like, wow, like males are taller, but this is here at a max of 6, and this one had a max of 5. What am I trying to point out here? Using frequency probably would have been a good one, and we'll talk about that later on. But if I transformed each of those into percents, that would have been more comparing apples to apples. Okay. Let's try some examples down here. Okay, now we're going to talk about how to use histograms wisely. Okay, hopefully you can recognize this. Put your finger on the one that's a histogram. This one in blue is a histogram. How do I know it's a histogram? They are touching. And of course this one has some gaps there between those little spaces there. Therefore that one is a bar graph. Why is that important for us? To make sure you are not confusing the two. Bar graphs in orange, if I asked you what kind of radio station or music do you listen to, the answer is what? Something like country, oldies. This is categorical. If I asked you, were you born in a different country? Okay. Or how many in the class were born in a different country? And this one would be numerical or quantitative. Okay. So that is a big idea of how those are going to be different. So you'll recognize that they're both percents, but one is categorical and the other one is quantitative. Okay. Let's go down to this one over here. Number 2. Number 2, what do I got here? Don't use counts in a frequency table or percents in a relative frequency table as data. Okay, so let's use this example. Let's say you are counting the length of number of letters in the first 100 words in a journal article. So you're counting them. You open up this magazine, and you're looking at all the words there, and each of the words you're counting how many letters are there in the first 100 words, and you're documenting it. So, for example, the first word you see, like I or A, that would be a count of 1, or has the word or B, B-E, there's 15 of them. And this is what, say, Billy made. Poor Billy. Okay? So let's write, don't do this. Okay. The values, this is probably better if he had said something like word count or the lengths. But he doesn't have the lengths. He counted and they're off too. So that's if I were going to do it correctly, I would do lengths of the word. And then over here, percentage. That would be a relative frequency or a frequency. So he switched them. Down here, up here, he should have 1 to 13, if that makes sense. But he switched them. He put the counts down here. Okay, so that's the mistake Billy made. So this is the correct one to do this. Okay. Number 3, use percents instead of counts on the vertical axis when comparing. Comparing just means you have two graphs. Alright, so let's just say Mary is interested in comparing the reading levels of the medical journal and an airline's in-flight magazine. So she's comparing two magazines here. She counted the number of letters in the first 200 words of an article in the medical journal and the first 100 words of an article in the airline magazine. So, medical journal, J for journal, and M for the magazine in the airline magazine. And it wouldn't make sense because Mary only read the first 100 words of the airline magazine, but in the medical journal, they're writing 200 of them. So it wouldn't be fair because the medical journal, you're reading deeper into the article. You're looking at more data. Okay. So no, don't look at that one. Okay. Green, yes. This one. Why I look at this one is because now you can just compare percents versus frequency of how the lengths of the words are. So that might be a better, it's better to compare percents to percents versus counts to counts. And the last one, number 4. Just because a graph looks nice does not make it a meaningful display of data. So I have two nice looking graphs here, and you're asking which one looks better. Okay. The left one, is it a bar graph or a histogram? This is a bar graph. Why? Because they are not touching. Histogram would have been touching, but remember what we did in the first one, in the above example, if it's a bar graph, it is categorical. If it's categorical, you can't look at these over here are numbers. So we should have used a histogram. So even though it looks nice, that one's actually incorrect. Okay. If I asked you, how many words are in your first name? So if your first name is Math, you have 4. The answer is 4 letters, M-A-T-H. Well, that is a number, so you should be using some kind of numerical quantitative graph, and the dot plot would be fine, or a histogram. All right, I want you to go to the next page, and there are just a bunch of examples here, so go ahead and pause, try them on your own, see if you get the lesson, and then we'll go over these together. All right, so you had some time to go over those questions about histograms. Let's go ahead and go over the answers with you. Example number 3, grades on a science test. In the histogram shown at the right, how many students made a grade of 90 to 90% on the science test? So what are they showing us here? They're asking for us to look at students who got on a bin or a class at 90 to 99%. Great. It's gonna be kind of hard to, I don't know if I can write on there. That is bad. Well, can I write now? No. Well, it is the last, sorry, I can't write on the screen. How do I do that? How many of those students? Well, you look at the far right histogram, the rectangle, and if you line up, that has a number between 6 and 7. Do you see it? And so, can I write this one? I can write it. That one right there. So that means the answer is how many? So there are 7 students. Use complete sentences. It actually verifies your answers when you are actually writing out a complete sentence because you understand context, which is a big idea for statistics. 7 students who made a grade of 90 to 99% on the science test. All right. Question 3B. How many made a grade of 50 to 59? Okay, so I see 50 to 59, and there is no bar, so that means 0. 0 students made a grade of 50 to 59% on the science test. Multiple choice. Which grade interval earned by the greatest number of students? So I recognize that this one has the highest, and I'm going to the very top, and so that looks like the answer is 11 students, and because that's the highest, that bin there is 80 to 89, which is choice B. Use the histogram at the right to answer each question. Which interval has the least number of presidents? So least, we are thinking of the smallest number or minimum amount. And it looks like, now pay attention. It says which interval. Interval is the class, let's write that, class or the bin. And the smallest number of presidents I see is right there. So that's that interval. The interval of 40 to 44 in age, it has the least number of presidents. Again, don't abbreviate your quiz or test, but just trying to go over these as fast as possible. Construct a frequency table. Excuse me. So I would just have to do 40 to 44 and just writing down all the bins or classes on the horizontal there. 50 to 54, 55 to 59, and 60 to 64, and 65 to 69. And then basically all I have to do is just count how many are in there. So that looks like there's 2, and that one's in between, so 6, 12, 12. I think that one looks like 7, and 65 to 69 looks like higher than 2, not halfway, so I give that one a 3. All right, so we did this one. How many presidents are between the ages of 40 and 44? And if I go here, I recognize it's between 0 and 4, so that would say 2. How large is each interval? Okay, this is a trick question, kind of, not, but if you write it out, super helpful. Look, 40, 41, 42, 43. Okay, pay attention. This one has 45, the next bin. So if you count those numbers, 1, 2, 3, 4, 5, the answer is 5 years. Okay, so it's helpful if you just write them out so you can see it. Okay, next one. Which group of students has a greater median? Think to yourself, what does the word median mean? That means the middle number. So I'm going to count up class A. You can do this. You can write numbers there. 4, it's a 6, 8. This is in between, so that'll be a 5, and then this one would be a 4. So if I add all those up, 4 plus 6 plus 8 plus 5 plus 4, this will give me 10, 18, 27. Let me double check that. Uh-oh, can I not count? 4, 10, 18. I think that's right, right? Okay, then I go over here, and I'm just counting up the number of students. So 2, 3, 5, 6, 8, and 7. So if I add up all those numbers together, 10, 24, 31. Okay, this just tells me how many students. So number of students in the class. Okay, why did I need to calculate that? Because 27 is an odd number. So this is how I think of it. 27 is 13 numbers plus 1 plus 13 numbers. Okay, I'm not going to write out all of their ages or how tall they are. Heights in centimeters, it says, right? So there are 13 numbers over here. There's a number in the middle, and there's 13 more students over there. Okay. The median is going to be the 14th number, the 14th student. So let's go ahead and find the 14th student. Okay, there are 4, 5, 6, 7, 8, 9, 10. And then right here, the 14th student is my median. Okay, I'm not looking to the frequency on the left. I'm looking at its bin, which is 140 to 150 centimeters. So the median for group A is this. We don't know exactly, but we just know it's in that bin. Think of bin like, I don't know, you stuff all your stuff or clothes in a bin. All right, let's look at this one. Okay, 31 is also an odd number. So I have 15, and then this particular number I'm looking for, and then 15 more students. So 15 to the left, 15 to the right. I'm looking where the 16th number is. 16th number. Let's find the 16th student, okay? And all we have to do is just by counting. So again, this is 2, 5, add 5 more is 10. Okay, pay attention. The 16th student is in this bin, which is 150. So group B, that's a B. The 16th student is in the 150 to 160 centimeters in height. Okay. Now let's compare these two numbers. It says, which group of students has a greater median height? So you're basically comparing the medians of both of these, and we're trying to figure out which one is bigger. 150 to compare to 160. 160 is, so group A is less than group B. Group B is greater than group A. So our answer is going to be B. Okay? And one more question. Which statement about the graph is incorrect? So I'm going to circle not correct, which means what we're trying to look for is one that's false. Which one is false? Okay. So here I have a histogram. They're connected. I see salaries by thousands of dollars. So 1,000 looks like this. So that means if I take 50 here, so this would be 50 times 1,000. That means this person is making $50,000. Okay? All right, so if I make my graph here, right, there's no data there, so it's going this way. Where is none of the data? If you're going skiing, there is no data to the right. So this is really what? Skewed right graph. But this one says left. So this is false. So that is our answer. But I'm actually going to go through all the other ones and they should be true to double check my answer. Okay? The median is in the 40 to 50,000th measurement class. Okay, so again, let's count up how many employees we got. I got 20, I got 8, and I got 4. So I got 32 employees. Okay, this is an even number. Okay, so watch. 16 and 16, correct? So this represents numbers employees 1 to 16, and this represents employees 17 to 32. Okay, that represents 32 employees. But I need to take the 16th and 17th person, and you add them together. So the 16th employee and how much they make plus the 17th employee, and then you divide that by 2. So it's between the 16th and 17th is what we're trying to find. Okay, so here is the 16th employee, and this is the 17th employee. But both of those are basically in between 30 and 40. So median is in the 40 and 50th. Double check that. They're in there. Average is 40 and 50,000. I also think that one's false. let's keep going. See what happens. There are 32 employees on this graph. That is true. We found that right up here. Okay. Let's pick another color. Let's pick blue. The width of each class is 10,000. So the classes are down here. And I do notice something. Remember, you're not to include it. It's not actually, if someone made 40,000, I would put them in this bin. So remember, I would associate this as 30,000 to 39,999. So what's the difference between those two numbers? I actually think it's 9,999, but I think they're trying to say that it's about 10,000, which is fine, which is true. Okay, so now now we're stuck between these two that we think. So let's look back at our notes and make a observation. All right, so if I think both of these are false, so I'm going to mark both of these. Which of these are incorrect or false? If they had changed this number to 30 to 40, then I would say that this one would have been true, but both of those are false. Good luck on now doing your homework. See you guys.